Hello, welcome back to Cracking the Cryptic, and hopefully I've addressed the slightly yellow room issue to an extent yesterday, and I'm looking a little less jaundiced today. Killer Sudoku is out. Do get the app. It's just proving unbelievably popular. If you are used to computer-generated Killer Sudokus, I think you're going to be blown away by the puzzles in this app. And there are more where those came from when we get around to the updates in a quarter or so. 3 months' time, I think, is when the updates are due. So do get a hold of it. It'll be great for a year or as long as it takes you to get through currently 40 puzzles, eventually 100 that are on the app. And of course, we have our other 5 apps available. Steam, Android, and the App Store are where to look for those. I don't know if I'm saying the right words there, but never mind. Now, also obviously on Patreon, the Tracking the Cryptid Hunt, we are not putting up the solution in the middle of the month. We are going to wait on that one because people are still working their way through it, and good luck to them. It's hard. Also, that Modern Art Sudoku pack is excellent. Today, returning to a hybrid of a couple of traditional forms of Sudoku, Arrow and XV. Now, in XV Sudoku, an X marks a junction of 2 cells which add up to 10, and V 5. These are the Roman numerals, obviously, for 5 and 10. And in Arrow Sudoku, the numbers along the arrow add up to the number in the circle. Now, some of these are not circles, they're pills, effectively. And therefore, the numbers along the arrow add up to the 2-digit number in the pill in those cases. And that will always be read left to right or top to bottom. So, which has become quite common in Arrow Sudokus lately. So I quite like it, actually. It provides a really welcome boost to the things you can get into an Arrow Sudoku. So this is from Johnny Kaufman, the operatic tenor who's sent us a few puzzles in the past. I've always enjoyed them, and I'm looking forward to this today. Doing a tiny bit of research, I see Jonathan Kaufman, who calls himself Johnny, is unlucky to virtually share a name with Jonas Kaufmann, who is a German tenor, but this is Jonathan, the American tenor. So maybe if you are called Johnny Kaufman, you have to sing tenor. Let's have a look at this puzzle, though. Do give it a try on the link below the video. And if you want to watch my solve, I'm going to start now. Let's get cracking. And we've got a lot of long arrows, but they've mostly got pills. Down here, we've got 2 V's in a box. So they have to be the numbers 1, 2, 3, and 4 to make up these 2 5s. This one has to begin with a 1. It is basically a 2-digit number that's adding 2 Sudoku numbers together. So that can't go above 17. So that's a 1. Because of the V, we know that's a 4. This is either 23 or 32. How could it possibly be 32? 9, 8, 7, and numbers can repeat on arrows, so that could be an 8. It is possible for it to be 32. How irritating. Okay. This is a 9 because of the X. And that means this is a 6-8 pair. So now this is a 7-5 pair. So now is this possible for it to be 32? With a 7 there. Yeah, still, no, hang on, 7 there. These have a maximum of 24. That's a maximum of 7. That is only 31. It must be 23. Nice. That's a nice break-in. Now, where do we go next? Let's have a look at, well, this X has to be odd numbers, either 3, 7 or 1, 9. This one can't be 1, 9 because of that pair, but that's not very... okay, but it's right, it's adding 5 numbers here. So it's 2, 3, or could it be 4? This would be 41 at a minimum, and then you could have 9, 8, and 9, 8, 7. Well, that is 41, is it? 17 and 24. Yes, so we cannot quite rule out 41, that would be 37. Yeah, it's possible. No! Yes, it's not possible for it to be 41. Again, it just falls short of that. If that was 41, this would be a 3-7 pair. This couldn't be higher than 7. And to make a total of 41, I just worked out, that could be 987. But this pair would have to be 98 then. And this couldn't be 9 anymore if this was 41. So 4 is not possible there. You know, what a long chain to reduce that to 2 or 3, and it may not help at all, but it is true. As we often say. Now, what else can we do down here? This, yes, this is adding 2 cells again. So it begins with a 1. No, that's not very helpful. It means this isn't a 4 up here because the next digit has to be a 2, 3, or 4. So that's a 9, 8, or 7. This can't be 37 because that's in a pill. 5 digits can only add up to a maximum of 35. So we can reduce one of the possibilities there. And up here, this is adding 4 cells, which can add up to a maximum of 30. Obviously, we can't have a 0 there, even though we could put one in these days. So that's a 1 or a 2. And that gives us a 1-2 pair in the column. Is that any use? No, not really. Okay, so this number as well has to begin... No, it doesn't. Well, with a 1 or a 2, that could be 21 or even 23 or 24. Here's another one. 2 cells, so that's a 1. So one of these is a 1. What about this one? Do we know anything about it? It's in this total. So that is 6, 8, or 9. I don't include 7 because this other digit on the X has to be 4, 2, or 1 and can't be 3 because of that. So if it's 6, it would have to be 1 there and 2, 3 there, which is impossible because of that. So it's not 6. If it's 8, this would be a 2. So then it would have to be 1 and 4, 3, and that is possible. If it was 9, this would be a 1. It would have to be 3 there and 2, 4 here. So there's definitely a 4 in this. Oh yes, we've got a 2, 3, 4 triple. So from every perspective, there's definitely a 4 in these cells. Therefore that, oh well, I knew that wasn't a 4 once I took 6 out of there. So we've got a 1, 2, 3, 4 quadruple. These others must come from 5, 6, 7, 8, or 9. We've got an effective 1, 2, 3, 4 quadruple because one of these in the X must be 1 or 3. So that too is 5, 6, 7, 8, or 9. Don't know how that helps. So this could be 12 if it was 5 plus 7. 14 in 2 ways, 13 in 2 ways. Not so helpful. Now, what else can we determine then about this? Has this changed now that we've got a 1 in the row? It can't be a 3 or a 4 because that would need a 1 on the arrow. 5, I suppose, is still possible. Okay, not that useful. Oh, look, there's a V here, moron. Okay, right, sorry, I'm not a moron. Just a little overlooking of something. Right, 14. So those two add up to 14. And they can't be 8 and 6 because of that pair. So they're 5 and 9. That's nice. 9, 6, 8. So this is 7. Now, I know that because it's not 1, 4, 5 or 9, 6, or 8. That leaves 2, 7 and 3. Now 2 is gone because of that pair, and 3 is impossible because of the 1 in the box, because they can't be 1 and 2. So that's a 7. This one is 3, 6. No, it's 3. Okay, so this cell cannot be 1, 2, or 3. This one cannot be 1 or 2. So the only way to make up this 7 is with a 3 there and a 4 there. That is right. Yes, I'm just rechecking my logic there. That works. So we've got a 9 in one of those cells. These add up to either 19 or 28. Hang on, 7, 3 on a 1, 2. That's not a 7. Oh, what else can we do? Look, that 4 is seeing that cell. Okay, a bit of brief scanning failure again then, but got that fixed now. This is now 5, 6 or 9. No, I'll tell you what, it's not 5 or 6, because this cell cannot be 1, 2, 3 or 4. And even if that was a 5, 6 would require a 1 there, which is impossible. So that is a 9. Which fixes 9 down here. This is now a 1. 2, 8, 9. There is a 9 in one of these 3 cells. So, of course, there's an X here again. Sorry, that's a 9. And that means that for this group to make 21, they would have to be 8, 7, and 6. That is just possible. Okay, 28 now in those cells. 2, 8, 9, 3. 28. Is that a huge number? It's not really. No, I can't quite see what to do with that. There might be something. Now, 9. This can't be 1, 2, 3, or 4. So it could be 5, 6, or 7, making this 4, 3, or 2. That can't be a 4 because of the 4 already in the column, so that's not 5. Actually, 7, 1, 4. Oh, excuse. Oh no, we've got someone who can get the door. That's fine. 4, 1. So one of these is a 1. No, look, there's definitely a 1 in one of those cells. So that is the 1 over there. Oh, hang on, I'd better. Right, sorry, somebody else was getting the door after all, although we might hear the buzzer again. Now, this is great. So 28, that adds up to 28. That's a 1, 29. These add up to 16. That's quite an average total. That's irritating. This is 5 or 6. Just 2 and 3 have to go in the bottom row, right? And 3 is there. So 2, 3, 7, 3, 2, 8, 9. This is from 4, 5, and 6. Yes. Still, that 21 total is irritatingly possible. Now, I don't know quite what to do here. 2 is in one of those cells. 4, 5, 3, 9, 1, 2, 9. Just can't quite resolve this. If I could either rule 21 in or out, I'd have real progress. Maybe there's 3, 6. No, that still works. It works. Oh, no, look, yes, 2 and 2. So there's a 2 on the arrow, and I can now rule 21 out. So that begins with a 1. That can't be 1 there. Ah, that's a 1, and it's not on the arrow. Now, 23. The numbers I've got left for this box are 2, 6, 8, and 7. Now, I list them in that order because 3 of them are even. And if I'm going to have 2 even numbers on the arrow, I'm going to have a third even number because that's odd, and we've got an odd total. So those have to be the 3 even numbers. 2, 6, and 8 adds up to 16. That makes that one a 7. This is also a 7. These can't be 2 because there's a 2 in the row, so that's 2. This is now 5 because of the 6, 8 pair. That still hasn't sorted out, that one. 6 or 8 here. Oh, now it has. This cannot be a 6, 7, 8 triple. Oh, because it's got a 2 on it. I've resolved that already. I'd forgotten that. Right, 1, 2, 8, 9, 3. There's a 4 on here. Now, let's add up this 28 total. We've got 11, and a 4 is 15. We've got 1 cell there, and 1 more here to make 13. So it's either 4, 5 or 4, 7 there, and I don't know which. That's very irritating. Okay, not to worry then. 1, 4, 6, 9. Do we know what this adds up to? No, definitely not. 9 has gone now. So if this was 14, it would be 6, 8. Still 2 13 possibilities, although actually that would take out a 2 here, which would take out a 7 here. I don't know. I don't know that I need to be thinking in those depths. This is a 5. That is just Sudoku, since I got that 7. That's not really adding to the sum of my understanding of this puzzle. 2, 4, 1 or 3. I must be looking in the wrong place now. This has gone so well up to this point. That can't be 7 or 9. These are from 5, 6, and 8. This could still be 20-something or 30-something, because I just don't know much about these yet. 1, 9, 6, 7, 8. No, they're not resolving themselves. This is intriguing. Okay, so if this was an 8, that would put an 8 on here. This would be a 6, it would have to be. That's quite possible, though. Certainly giving me some pause here. Right, maybe this is relevant. If that's an 8, what did we work out? That this was 1, 4, 3. If it's a 9, it's 3, 4, 2. No. Yes. No. I don't know what. I barely know what I'm looking at the moment. Let's just refocus a bit here. So there's a 2 on that. 9, 3, 4, 1. 5, 7 or 8 it goes with. So we could have 7, 11 is the minimum. 16 is the maximum. That's not very helpful. This lot adds up to 19. Can I use that? Well, I know that's... Oh, this is an X. So that is 7 or 8. I keep missing these X's when they're in the pills, which is very foolish. 2, 8. Then that would be 5, 6. Or 3, 7, which would make that 9, 1. No, that's still... So this is either 37 or 28. 37's quite high. If that was 24, these would have to add up to 13. Yeah, they could be 6 and 7, for instance, or that could be less than the 24. There is room for that. If this was 28, 2, 4, 6, 12, yeah, no problem really. Okay, we're going to need to find some other breakthrough. I'm sorry about this. And you're probably seeing what it is right away and telling me. And I don't know what it is. Right, one of these is a 1. One of those is a 1. Let's pencil mark that in. 9 could easily be on this 19 total. 19 is a very middling total for 4 cells. Almost averages 5 exactly. 1, 2, 3. 4 has to be on one of those. That doesn't seem like it can possibly help. 2, 3, 8, 9. Wow, I think I might have to work out what this 28 is. So, if it was 4, 5 here, that would put an 8 here. That would put 6 here, 7 here, and that doesn't work immediately because you'd need another 6 here. If that was 4, 5, it would go with an 8, and then where would the 6? Where would 2 6s go in these boxes? They'd both have to be in the same column. So there we go. That's what I wasn't seeing. So that's a 4, 7 pair. 11, 22. This is the 6. 6, 8 here. So now this is a 3, 8, 5 triple. So we can get rid of 8 and 5. This now adds up to 9, either 13 or 15. Still don't know what that is. 9, 2, 7, 3. We do know what this is though. That's a 6, that's a 3. That does fix that pill. 15. That puts the higher number on. 5 here. This can't be a 3, and if it was 14, that would be 6, 8, which is now impossible. So that's a 2. That's a 4. This is 3. This is 9. That's a 1. Surely it is all coming together now. 12 means that's 7 and 5. This is 6 and 8 as a pair. 37, it is the higher number. That's quite surprising. So the maximum this can be, it's actually not 986 because of that. It's 985, which is 22, and would need another 15. So there'd be 2 degrees of freedom from the absolute max. Ah, and 7 is not possible. Oh yes, that's a 9-1 pair now because of the 7. So that's put a 9 on the arrow. One of those is a 5. In fact, the 5 is here. So that's a 6 or an 8. So we haven't... Oh, I don't think this can be a 4. If that was a 4, 21, 30... Oh, 4, 9, 7, 9, 8 would work. Oh, it can't be 4, 9, 7. I mean, this is the limpest reason. Actually, let's just fill in all of these possibilities. They are 4, 5, and 7. And the 5 has to be here because of the 5s here and here. So 4 and 7 go in like that. Right, now we've got a 5 on the line, 14. These other 3 add up to 23. Now, they don't have to be 9, 8, and 6 because there could be a repeat between those 2 cells. But they probably are 9, 8, 6 because 6 repeating there isn't enough, and 8 can't repeat in those 2 cells. So they are 9, 8, 6, which can work 2 ways round. Okay, so that's not resolved yet. Wow, still not done. That's fascinating. Right, 8 goes here by Sudoku. That is 6 or 9. So 2 is here. 7, 2, 3, 9, 4. That's 6 or 8. We're going to have to use this 19 total in the end. I do believe. That's a 5 because the 5 can't be in either of those cells. That is a naked single 6, and the naked single, as so often, a late appearing naked single does the trick, because that makes that one 9, 6 here, 8 here to make the numbers up. 6, 8, 6, 8. That's a 9, 7 and 4. Yes, 3 and 8. Everything seems to be coming together now. Even that 8-6 pair that was so hard to resolve. Still got a 2-4 pair to deal with there. So that makes... Oh, well, let's have a look at this total. 14, we need another 5 here. That's got to be 3, 2. What a good puzzle. I mean, that's worked really nicely throughout. I mean, I like puzzles like this with nothing massive, but a nice flow throughout the puzzle. And I think that is correct. Well, that says that the Sudoku all works. Hopefully I've got all the totals right and all the XVs. So there we go. That is Johnny Kaufman's XV Arrow Sudoku, and much fun it was too. Thank you very much, as always, for watching. Please do subscribe if you haven't already, and get over to Patreon. Great stuff there, and buy those apps. And Merry Christmas. Bye for now.